Hi there, my name is Lily Sears and I'll be your host. Welcome to the morning show. Today we're going to explore what happens in and around an atom. We're going to have several special guests with us today, and one especially to note and look forward to later in the program is Mrs. Periodic Table. But first up, Mrs. Proton. So, Ms. Proton, can you tell us a little bit about yourself? I'm so happy to be here, and well, to answer your question, as some of you know, I am a stable subatomic particle. And I have a positive charge. I am found in every single atom's nucleus. Can you believe it? Every single one. I'm there. Also, I am like 1,836 times the mass of Mr. Electron. Ugh, so negative all the time. Can I tell you about this one time let's just say I wanted to know how many protons were in an atom. By looking on the periodic table, how could I do this? Well, as you mentioned, first you need that periodic table. Yeah, that's the thing. And then you look at the atomic number. If you don't know what that number is, it's the little small one up in the top corner. Thank you so much for being here with us today, Mrs. Proton, and opening our eyes into how to find you in an atom and what your role is. Next up, we have Mr. Neutron. Hi there, Mr. Neutron. How you doing today? Meh. Why don't you tell us a little bit about yourself? I am a neutral subatomic particle. Oh, how interesting. Could you tell us a little bit more about how you compare to other subatomic particles? I am marginally greater than a proton and 1,839 times greater than an electron. Let's say, Mr. Neutron, that I had a periodic table in front of me and was looking at an element. How could I figure out how many neutrons were in its nucleus? You take the atomic mass and subtract the atomic number from it. Thank you for that enthralling interview, Mr. Neutron. Next up, we have Sir Electron. Good morning to you, Sir Electron, and thank you for being on our show. How are you on this fine day? Could you please tell me and the audience a little bit about how you compare to the other particles and a little bit more about yourself? I am like the lightest subatomic particle, and I guess I have a negative charge. That's what the nerdy scientists say. I know I'm like 1,836th of the mass of a proton. Therefore, I'm considered nearly massless, and I'm not even calculated when the mass is calculated because they don't think I can be enough. So, no, that's not fair. I guess, though, since I'm only a small amount, I guess, but it still doesn't seem right. And I'm also nearly massless with an electron and proton. So positive. Why would I even want to be counted with her? Thank you, that was very thorough. Can you now tell me how I would be able to find you if I had a periodic table with me? Do I have to? Yes, you do. Fine, whatever, I'll do it. Well, in a stable atom, you look at the atomic number in the same spot you would find the protons. Ugh, Miss Proton, so positive all the time. Anyways, that's how you find how many of I are in. Especially if we're on the periodic table, it's the same amount. So Electron, thank you for being here. After a break, we'll explore the differences between a neutral atom, an ion, and an isotope, so stay tuned. Welcome back from break. In this segment, we will ask an expert. Our expert we have on the show today is Mrs. Periodic Table. So, Mrs. Periodic Table, you have quite a few elements on you. How can you differentiate between the neutral, the ions, versus an isotope? Well, yes, hello there. I'm happy to be here. The first important thing to note is that all atoms on me are neutral. After that, it's fairly simple to find out, the differences between the neutral, an ion, and an isotope. First, you're going to start off, and you have to know the difference between the three to be able to identify them. And the difference is a neutral atom has the same number of protons as it does electrons. And this makes it neutral, meaning it has neither nor positive nor negative charges. As for an ion, it has one or more electron than it does proton, or vice versa. And finally, an isotope is an atom of the same form. This means they have the same letter on my periodic table, but what the difference is their atomic mass and their physical characteristics can greatly differ. Fun fact, every chemical element has at least one or more isotopes. Okay, so now we know what they are, but how are we to identify them? Yes, how do I identify them? Well, as I said before, every element on me is neutral, so don't look on me expecting to find an isotope. Next would be other elements can be identified as an ion if they're written with an A plus or an A minus next to them, slightly above. An example would be hydrogen with a small minus sign. That would mean it was a negative ion. How do I identify? An isotope is also fairly simple to identify. All you simply have to do is you have to see if it has the same letter but different numbers next to it. An example would be lithium with a 7 and a 3, and lithium with an 8 and a 3. Those are isotopes. They're the same element, but they have different atomic masses leading to different properties, and that's how you figure it out. One more question for you, Mrs. Periodic Table. How does an abundance of a certain element affect the element's average atomic mass? You're right, this is a tougher question, and it's a little out of my league, but I shall give it a shot. Abundance affects the amount because elements, they occur in different amounts naturally. Each isotope has a different mass, and so if they occur in different abundances, it has to affect the average. Think of it like this. You have a pile of objects in front of you. They weigh 3 different pounds. 10, 2, and then 3. If 90% weigh 10 pounds, and 5% weigh 3, and 5% weigh 2, you can't just add the 3 up and divide. That's not going to get you what you want. You have to change your problem so that it reflects that 90% weigh 10 pounds versus only the collective 10% that weigh 5 pounds. It's that simple. How you do this is you take the number and multiply it by the decimal form of your percentage. For example, 10 times 0.9. You do that to all 3, add them up and divide just like you would. So the process remains the same with an added step. I could get more in depth, but that's a much longer conversation for another day. That's all we have time for today, folks. Thanks for watching. Make sure to tune in next time where we take a deeper look into the world of insects. Till next week, this is Elise signing off for the morning show.